Hello viewers, this is Ronald taking you through this tutorial for O-level physics, and this tutorial we're going to talk about questions on electrostatics. Now these are the very questions I left in the previous video, and I believe by now you have already tried them out and ready to mark yourself and check your progress. So we shall start with question 4. Remember, it's a continuation in the previous video. So question 4 says that it came from UNEB 2014, paper 1, question 44, and part A says that state the laws of electrostatics. So here we shall say that like charges repel each other and unlike charges attract each other. So that those are the laws. So if you wrote that, it would be half a mark for like charges repelling each other and another half a mark for unlike charges attracting each other. So basically that's how the 1 mark could come about. Now we shall go to part B. Part B says that a small metal sphere carrying charge is lowered gently into a metal can placed on the cap of an uncharged gold leaf electroscope. So note that this is uncharged gold leaf electroscope as shown below. So this is a metal sphere lowered gently into a metal can placed on the cap of an uncharged gold leaf electroscope. So Roman 1, they say that state what happens if the leaf of the electroscope, state what happens to the leaf of the electroscope. So here I shall say that the leaf diverges, and that will be 1 mark. Then Roman 2, they said explain the observation in B Roman 1 above. So here we shall say that when a positively charged metal sphere is lowered gently into the metal can, it induces a negative charge on the inside of the metal can and a positive charge on the outside of the metal can. So let's see how that happens. For example, this is a metal sphere. It is positively charged, so it will induce a negative charge on the inside of the metal can and a positive charge on the outside of the metal can. So that we shall say that the positive charge on the outside of the can attracts negative charges from the brass plate and the gold leaf, leaving both the brass plate and the gold leaf with a net positive charge, which makes the leaf to diverge, as you can see here. So these will remain with a positive charge, and in that case, since like charges repel, it means that the leaf will diverge. So basically that's what they wanted, and now let's see how marks could be awarded. So that is half a mark, half a mark, half a mark, half a mark. So basically that's how the 2 marks could be got in this part. So that has been question 4. Now let's go to question 5. So question 5 came from UNEB 2012, paper 1, question 43, and part A says when a balloon is rubbed with air, it becomes negatively charged. Roman 1, explain how the balloon becomes negatively charged, and they give it 2 marks. So here I shall say that when a balloon is rubbed with air, heat is generated which enables the electrons to be detached from the air molecules and gained by the molecules of the balloon. The balloon thus becomes negatively charged. So basically that's what they wanted. Alternatively, you can also explain it in this way. you can say that when a balloon is rubbed with air, the balloon gains electrons from the air by friction. And after that, we shall say that the excess electrons on the balloon then gives it a negative charge. So basically that's what they wanted, and now let's see how marks can be awarded. So for the first explanation, that's how the 2 marks could be got. What about for the second explanation? So that's how you could get the 2 marks for any one of the explanations. Now let's go to Roman 2. Roman 2 says, compare the magnitude of the charges acquired with the balloon with that left on the air. So here shows that both charges are equal in magnitude. Remember, they should be equal and opposite, but remember they told us to compare the magnitude only, so we shall just say both charges are equal in magnitude. And if you read that, you'll be able to get yourself full mark. Now let's go to part B of this question. Part B says that the diagram in figure 10 shows electric field lines around a metal sphere in air. So this is the diagram, and they ask what will happen to the charge on the sphere if a sharp spike is placed on top of the sphere. Here we shall see that the charges will leak through the sharp spike and the sphere becomes neutral. If you wrote that, that will be 1 mark. So basically that has been question 5. Now let's go to question 6. Question 6 came from UNEB 2006 paper 1 question 45 and says that figure 10 shows a negatively charged ball B inside a hollow metal conductor P resting on an insulator. As you can see here, this is figure 10. Describe the distribution of charge on the metal conductor Roman 1 before B touches P. So here we shall say that before B touches P, an equal magnitude of negative charge is uniformly distributed outside P, while an equal magnitude of positive charge is uniformly distributed inside P. So basically that's what they wanted in Roman 1, and let's see how that comes about in the diagram. So this is the diagram. Before it touches this hollow can, inside it will be positively charged and outside there will be a negative charge. But remember they said it should be equal in magnitude. For example, this is 1 2 3 4, so inside there should be also be 4 1 2 3 4. That's what is meant by equal magnitude, and also outside they said equal magnitude, so 1 2 3 4. So when you're showing these charges, you should have that in mind, that they should be of equal magnitude. So if you wrote that, that would be that's how the 2 marks could be got. Now Roman 2 said, explain what happens after B touches P. So when B touches P, we shall see that the positive charge inside P is neutralized, while an equal magnitude of negative charge outside P remains. So basically this is what happens. Inside there is no charge at all, but outside the charge remains. So if you read that, that's how the 2 marks could be got. So I believe you have marked yourself and checked your progress. So what I'm going to do, I'm going to leave you with another set of questions still under the same topic of electrostatics. But be reminded that this topic is taught in Senior 2 Term 3, implying that if you're in Senior 2, Senior 3 and Senior 4, this video will be best for you. brings us to the end of this video. Thank you for watching, and be reminded that the solutions to the assignment left will be available in the next video. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video with the solutions has been uploaded. Otherwise, thank you for watching, and also if you know of any student who is not on this platform right from senior 1 to senior 6, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.